Hi, everybody. I thought I'd make a short video showing you how to do, or how I'd like you to do, the in-class quiz of this past week. So here's the quiz. I just copied it and pasted it into R, and so let's get going. And first thing we do is we need our library commands. So we'll have tidyverse, and that library should be lowercase. And then I'll copy it. I double click on my mouse and double click on the word, the model summary, right? And then my drop down menu gives it, right? So I use my cursor a lot to double click on things. Um, so then what I want to do is read in the data set. Here's the data set. So what I'm going to do is just call this URL and give it the assignment. And then I'll go to the end of it. So I click down here and go there. And then I use my arrow key to go to the other side. That way I'm not going around on the cursor, just a trick to do. So now I can delete this. And once I run my URL, now it's in my environment. Now I can um, read it in, and it's a CSV file. So, and I'll call it df just to keep things simple. And the command to read is read.csv, and I'm reading the address in. So I don't know why people are calling their data sets GitHub. Seems like kind of a long word. Just call it df for data frame. Far simpler. Um, Now it says to use the table command to see the values of the two character variables. Well, the table command is table. This was in Appendix A of the textbook Introduction to Econometrics. This is the very first things we learned using R. Many people forgot that. The syntax is df dollar sign, and then I don't have to retype it because the drop-down menu will prompt me for it. And now I'll copy the same thing and I'll put df, but instead of marital status, I'll put race. So the table command gives me the frequency of each value. Uh, so marital status is a character variable. We can see that here. So it has a number of levels for marital status. If I run this command, I see that 6,633 of the 48,000 people in the data set are divorced, 37 are married AF spouse, 22,379 are married CIS spouse. So I see right away, what the shares are for these. So nothing terribly difficult there. And now I can also do DF dollar sign race, and I see that Asian Pacific Islander is 1,500, Black is 4,600, and white is the minority. So I have seven groups here, one, two, three, four, five, six, seven, and I have four groups here. So the instructions tell me create a set of n minus one dummy variables for the two character variables. So marital status has seven. I should create six dummy variables, but this one I notice only has 37 observations. So maybe I'll just group them as married, and maybe I'll just group all the married people together. So I'll exercise a little discretion here. So I'm going to create a new variable, data frame, dollar sign, married. I'll just call it married, and I'll make it be a dummy variable. So I have my if-else statement. Um, and the variable is marital status. So instead of typing it out again, I just double click on it. Command C will enable me to paste it. Much faster to do it that way. So if marital status is equal to married AF spouse, and now I'm going to use the or symbol, and I'll put it on a new line, and I'll just copy this whole thing. So I'll have married civ spouse. And then I'll copy it again. I'll line these up so that they're kind of lined up. And then I'll have married absent spouse. So if marital status is any one of those three, so it's if it's this one, or if it's this one, or if it's this one, then the dummy variable married that I'm creating in the data frame will be a 1, and otherwise it'll be a 0. So that's my if-else command. I now have a new dummy command variable. This should go to 10 when I run this. I run it, and oh, I didn't give it the two-part address system, right? DF dollar sign, because it's base R code. So it had no idea what marital status was. And now we see 10 values, and I see married is a bunch of zeros and ones. So I created one of the dummy variables. Now I can just copy this and adapt it. So I'll have a dummy variable for divorced. And maybe I'll call this married dumb, just so it's clear it's the dummy variable. Uh, and maybe call this one divorced dumb. And I see here that divorced is written like this, divorced, so capital D. So I'll copy that here. And in this case, divorced is only one category, so it'll just be 1, 0, and close. So now I can read everything, I'll read it in again. And now I have married dumb and divorced dumb. So I've got two of the dummy variables, and I have widowed. So let me do that one. So I'll just copy widowed here and paste it here, and I'll call it with dumb. So if I run that, now I have a dummy for widowed, and then I'll have separated, right? And then I'll let my omitted category be never married. Um, so separated. And I'll copy this here. So my omitted category will be never married. There's 16,000 of them. There we go. We have our marital dummy variables. Now we do the same thing for race. So I can just, again, instead of retyping, I'll just copy everything. Now my condition will be race. I could see that it's capital black, right? I see right here, black with capital letters. I'll call it black dumb. These are simple now once I get the hang of it, right? And this is your goal, is to practice this so that you get the hang of it. I'll make a dummy for white, and that would be, I'll copy it here so that I have the exact wording. And then this one, I'm going to make it just be Asian because it's a little too long. And many of you notice that you can't name a variable um, with dashes in it. So now I created my three dummy variables for ethnicity. I'm not going to make a dummy variable for other because that would be a dummy variable. Black, white, Asian. And that's all the prep now. I'm ready to, let's see, I need to create a new variable that's the log of income. And I see in my regressions, I also need the log of education. So I'll do those. I'll do those in tidyverse. So I take the data frame, it's going to be assigned back. I pipe it into the mutate command, and I'll have um, log income equals the log of the variable is called income. So pretty straightforward. I could add a +1 there if there were zeros. I'll worry about that if we run the regression. I could do both of these in the same one. So I'll do log education equals log of, oops, education. And again, there may be zeros in education. Actually, run the table command for education. So I'll go back up here and just run this real quick to see. It's not called education, it's called years underscore education, right? So now I see that my syntax would have been bad. And I see there's no zeros anyway. So I'll copy education down here. So now I have the log of income and the log of education, both created in the mutate command. I could put this on 2 lines, that way it's clearer. Notice since I didn't run the library commands, it didn't find the pipe function, so I need to run the library commands. Now I've run them, I can go back down, and I have my two new variables. And so then it's just regressions, right? So I can delete all this. So I'm going to have R1 and I'll assign it or equals linear model. So that's the regression I'm running. So it's the log of income. And the first one just has education and age, and education is not logged in this first one. So it's years of education plus age, and the data equals what? DF, because that's what I called it. So that's my first regression. Now I can run my second regression. So very fast, I'll just copy that R2. And the second one is two dummy variables indicating marital status. So I'll put divorced, dumb, and widow, dumb. So just ask me to do two, so I'll do those two. Uh, Third says the log of education and some the dummy variables for race. So instead of years education, I'll get the log of education. And instead of these dummy variables, I'll have black, dumb, plus white, dumb, plus Asian, dumb. And let's run these to make sure that they run. No error, no error, no error. And I see them that they're here. So I've done these, and I have two more. So now I'll copy our. Oh, I see. Uh, this is asking to do a subset, so with just education and age. So I'll call this R4, and it's the log of education. But now my data frame is a subset, so I'll put subset, open parenthesis, and the condition is that it's white. So I could do that two ways. I could have the white dumb equals 1, or I could go up here and get race equals double equals white. Either way. Notice since I opened a parenthesis here, I have to close that parenthesis there. So that's R4. Works just fine. And then the last one is Asian. So same thing. And I could copy this. Two different ways to do it, right? Same thing. Since I'm telling R the data set right here, I don't need to have the DF dollar sign Asia Pacific. Um, and there's my I needed to call that R5. So this is 1, 2, 3, 4, 5. So let me run these two again. Now I can delete. I'll gather the them as a list, R1, R2, R3, R4, R5, and maybe I'll give them some labels. So this is Asian only. This is white only. The other ones are pretty obvious, so I don't need to, won't give them labels. So that's my list of the 5 regression specifications, right? Different specifications that we have. Some of the specifications are to limit the sample, and then I'll display them. Model summary. Um, I'm going to display all 5 regression results. I have stars equals true, so I see the asterisks. I have the standard error be robust, so it's the correct standard errors for heteroscedasticity, chapter 4, all the way back to that chapter. And then, I could give it a title and things, but I'll let you worry about how to do that. And I didn't run this first, so I need to run the list. So I was in the wrong place. There's the models. There's the people ask me why doesn't this one have how the megabytes? And maybe there's a rule that if it's less than 10, it doesn't display that. I have no idea why it does it for these 4, but not for this one. There's no Could be some other rule. Here are my regression results. Notice how my titles are pretty succinct. Um, the log of education is the explanatory variable in these, and the log of income. So this is elasticity. For each 1% increase in education, income of whites goes up by 6.68%. For Asians, each 1% increase in income, education goes up by 0.86%. One is bigger than the other, but we don't know how to do the test to see whether these different regression coefficients estimated with different samples, one is for whites only, one is for Asians only. We don't know how to do the hypothesis test of whether those two coefficients are equal. Can we reject the null hypothesis that the two coefficients are equal? So we don't know how to do that hypothesis test. It could be that this is within the margin, the confidence interval for the difference between two coefficients estimated with separate samples. Notice that the sample size for Asian is quite small. That's probably why it's less than 10 megabytes, perhaps, if that's the rule. The sample for Asian is quite small, so randomly we're going to get different coefficients for Asians just because we have a smaller sample size. So these two coefficients may not be, if we had the appropriate hypothesis test, if we knew how to do that and construct a test statistic for that, we might not reject the null hypothesis that the coefficients are equal. One thing we could do is do a regression and interact the log of education with maybe the Asian dummy and the black dummy and see whether that generates any difference. So let's run that. So I'll take the longer regression, and this was what many were supposed to do in the lab. I can use the I formulation, the capital I, and I have log education times uh, black semi-variable plus, uh, oh, I needed to close this here. And then I'll copy the whole thing and I'll do it for white or Asian. Asian. And I think my syntax is right. No, I have a comma there at the end. Uh, I have two parentheses. Yep. Yep. So now I can add our six here. I'll call it interacted. I'm curious what it generates. So R6 is, let's make this bigger. Here's my sixth regression. Get roughly the same for log of education. And now we see that the log of education interacted with the black dummy is not statistically significant. So the effect of education on earnings is not different for people who identify as black compared with people who identify as white in the data set. But for Asian, it is larger and fairly substantially, but it's statistically significant at the 5%. So usually one asterisk is the 10% level, but in model summary, it's the 5% level. Yeah, so we do find some interesting result there that maybe the relationship between education and income is steeper for Asians in the labor market. I'm presuming this is US data. I don't remember where this data came from. So we do find a little bit of difference there. So we interpreted the coefficient on log of income. Um, Notice here, the outcome is just regular income. So we interpret the coefficient as 1 year of education is associated with a 9% increase in income. Age, similarly here, 1 year increase in age is associated with a 1.4% decrease in income. Um, the We didn't log age here, so it's not clear that this interpreted the same way. Um, widowed Interesting. Widowed people seem to have lower, if it's a sample of men and women. I can't remember what the sample is, right? So we do find some interesting things that you can comment on. Great. Hope you found that helpful.